Hi everyone. Today we are going to talk about proportions. So I suppose I should answer what a proportion is before we get started. A proportion is basically an equation that says two ratios are equal. And maybe I'll just say a statement, which is in the form of an equation, but it's a statement that says two ratios are equal. And why are we talking about proportions when we're talking about scaling? It's because a scale factor we defined as a ratio of measurements. So if I'm saying a proportion, I'm setting up something that says, or I'm setting up a statement that says two scale factors are equal. Okay, so let's unpack this. Here's an example. Let's say you have a scale map of the world, and the world is 3.5 inches wide on the paper and 1.75 inches tall. So on the paper, the width, this is the widest part, so we'll say that this is 3.5 inches wide on the paper, right? That's not really the width of the whole world. And the height is from here to here. Its tallest part is 1.75 inches tall. 1.75 inches. Okay, and the key given is that every inch on our map represents 7,100 miles in real life. This is one way to write a scale factor. So for every 1 inch, this means corresponds to 7,100 miles. I can also write it this way. 1 inch corresponds to 7,100 miles. Okay, this is another way to write a scale factor, and this is the way we'd write it as a ratio. So let me think of another example of why you might want to write it this way. Okay, so this has nothing to do with this example, but let's say you're drawing a net of a 3D object, and you start with an object that is a rectangle, so rectangle like this, and let's say that rectangle measures 4 inches by 2 inches. And let's say you scale that by a factor of 2. So if you scale by a factor of 2, you're just going to multiply all the dimensions by 2. So then you'd get a new rectangle that is, let me try to draw this out, 8 inches by 4 inches. So this is a scale copy of the green one. In order to figure out the scale factor, I mean, I told you it was 2, but let's say I didn't know that. Let's just say I gave you this picture. To compute it, what you would do is divide the dimensions to determine what it was multiplied by. So I would take 8 divided by 4, which gives me the 2. Okay, so that means I enlarge the green rectangle by a factor of 2. But what I need to know is that this is the way to write it as a ratio as well. So for every 8 inches, we started with 4 inches. That's what this means. And that also has to be equal to the scale factor to go from the different heights of the rectangle. So that should be equal to 4 divided by 2. 4 divided by 2 will give me 2. 8 divided by 4 will give you 2. So these are equal. Okay, so this is how I would compute the scale factor. This is why we're talking about ratio. Ratio is really a way to write the scale factor. Okay, now why might I want to do this? Now let's go into that. So if I wanted to use a scale factor to determine the circumference of the Earth, there's a couple ways I could do this. Well, the circumference is going to be the width around, if you wrap this up, it would be the length across here. So I know this is broken down into 3.5 inches. So let's say this is 1 inch, this is 1 inch, this is 1 inch. Ooh, I didn't really draw that very accurately, but the last one would be 0.5. Maybe I'll retry that. Let's say this is 1 inch, this is 1 inch, this is 1 inch, and then this is like half an inch. So each of those inches would be 7,100 miles, except the last one's only half an inch, so it'd be half of that, which is 3,550 miles. And I could just add those up to get what the distance is in real life. Or I'm repeating, adding 7,103 times, and then a half. So another way to do this is I'd have to take 7,100 and add it 3 times and a half a time, which is really multiplying by 3.5. If I do that, I'll get the circumference of the Earth. Basically what I've done is I've multiplied by the scale factor, so I've just scaled it up. 7,100 times 3.5 will give you 24,850, which makes sense for what the circumference of the Earth would be. Okay, that's one way to do this problem. Now, another way to do this problem, and I'm erasing because I want to show you how we could do this with proportions, but that method will work too, is I can set up a statement that says two ratios are equal. So the ratio of 1 inch to 7,100 miles is the scale. Okay, 1 inch to 7,100 miles is another way of writing our scale factor. Okay, and now a proportion is a statement that says two ratios are equal. So the scale of this has to be equal to how I'm going to scale the circumference. So for every 1 inch, it's 7,100 miles. For every 3.5 inches, I want to figure out how many miles that is, which I don't know. Okay, but 1 inch goes to 7,100 miles, 3.5 inches goes to X amount of miles. Instead of calling this question mark, I'll call this X, and you can even write X miles. Now the reason I set these equal is because the scale has to be the same, and if these ratios compute the scale factors have to be equal. Now this is an Algebra 1 skill. In terms of solving it, we're going to use cross multiplication. So I'll multiply across the two diagonals of my proportion here. So let's go ahead and actually do that. Okay, so here are my diagonals. So across this diagonal, you have 1 times x, which is just 1x. And then across the other diagonal, you have 3.5 times 7,100, which equals 24,850. Now, 1x is just the same as saying x, so I already have solved this without doing any additional work, and you get the same answer you got when you did just multiplying by 3.5. Okay, but a proportion can be used in a proportion can be used every single example, whereas the multiplication thing doesn't always work depending on what you're doing, such as part B. So a total distance across the U.S. is 2,802 miles. So if I find the U.S. here, the distance across here in real life is 2,802 miles. What it wants to know is how you would find the distance on the map given the scale. Okay, so what I saw a lot of students doing, and please don't write this down, what I saw a lot of people doing is doing 2,802 miles times some number. So like some people multiplied it by 1 inch, some people multiplied it by like 3.5, and then you'll get like a really big number. And does it make sense that the amount of inches this is on the map is a big number? No, it shouldn't be, because across the whole Earth is only 3.5 inches. So this little piece is probably even less than an inch. So when you say, does your answer seem reasonable, I want you to think about that. What we can do to solve this is set up a proportion. And you can always flip this around if you want. So I know for every 7,100 miles, it corresponds to 1 inch. Okay? Or I could write that as 1 inch goes to 7,100 miles. It doesn't matter as long as you keep it consistent. So if I put miles on top, you want miles on top over here. So we have 2,802 miles for the distance across the U.S. I want to know how many inches that is on the map. So the scale factor should be the same here, and I can call this x. Okay, you can also set it up this way, where inches are on top, so your x is on top, and your miles are on bottom. These will give you the exact same answer. You just have to keep it consistent. Inches to miles compares inches to miles. You can't do inches to miles and then compare miles to inches. It's not consistent. So I want you to pause the video and go ahead and do cross multiplication to solve that. I'll come back with the answer. Okay, no matter how you did the cross multiplication, which equation you use, you should get about 0.39 inches, so less than an inch, which that does make sense because if the whole circumference is 3.5 inches, our distance across the United States should be a lot less. Okay, so what I did is I multiplied 7,100 times x and 2,802 miles times 1 inch. So that's where I got this equation here. To x alone, x is being multiplied by 7,100, so to undo multiplication, I did divide by that. Divide both sides, you get x is 0.39 inches. Okay, which makes sense. Basically what you're doing is you're reducing the size. So I started with miles. I wanted to reduce the size to inches. So if your scale factor is basically, multiplying by 7,100 here, to get the scale factor here, you'd have to divide by 7,100. If you divide, you'd reduce. So it's like enlarging something by 2 versus reducing something by 2. Either multiply or divide by 2. Okay, we'll do one more example. Or at least set it up. So you decide to make your inflatable shape a 6-foot-tall rectangular pyramid. Sounds awesome, right? It's going to be a cool inflatable shape. You want the base in real life to be a 4-foot by 3-foot rectangle. Okay, now when you're planning the construction, you're going to want to draw a net so you can see what it's going to look like. You can get all the details narrowed out before you actually construct it. Now, if you're designing the net, you decide you want one of the dimensions of the rectangular base to be 3 inches on the paper, because you're just putting it on a sheet of computer paper. The question becomes, what should the measurements of your other dimensions be? And this is something you'll have to figure out. Okay, so I know I'm working with a rectangular pyramid, which looks something like this. It's got a rectangular base. It's a pyramid, so all these will meet at the top. Obviously, your net would be a lot more accurate. You want it to be 6 feet tall, and you want your rectangle to be 4 feet by 3 feet. Okay, but on the paper, you're going to draw that rectangle. The length is going to be 3 inches, so the length of this one is 4 feet, so this side you want to be 3 inches. And I got to figure out what the other dimensions are going to be. And you can use a proportion to solve this. So for every 4 feet in real life, that corresponds to 3 inches on the paper, because I'm comparing the length to the length in inches. Okay, now if I want to determine how wide this shape should be, so I know in real life I want it to be 3 feet. I don't know how many inches to draw that as on the paper, so I can set up a proportion to solve this. Okay, or I can also solve a proportion to figure out how tall I should draw the shape on the paper. So my scale is still every 4 feet corresponds to 3 inches on the paper, because that was the piece of information I had. Now, if I want to determine how tall it should be, I know in real life it's 6 feet. So feet to inches compares feet to inches, which I don't know. And what I want you to do is I want you to solve these two proportions for x and tell me how wide should I make the rectangle on the net and how tall should I make the net as well. Okay? And if you have any questions, please ask them. But essentially, that's how you use a proportion to determine missing dimensions or determine how to scale something. Again, keep in mind that a proportion is a statement that says two ratios are equal. And a ratio is a way of computing the scale factor. So really what you're doing here is setting the two scale factors equal, because if you're going to scale something, you have to scale all the dimensions the exact same. And if you scale all the dimensions the exact same, the scale factors should always be equal.